In this second section of the appendix, A2, we're going to look at polynomials and factoring of polynomials. Specifically, we'll look at three operations, addition, subtraction, and multiplication of polynomials, and then we'll look at some patterns and ways that we can factor polynomials as well. To begin, let's look at just a couple of simple operations with polynomials. We'll look at addition, subtraction. This one happens to be a subtraction example, but addition would be no different. And then we'll look at a product, a multiplication problem as well. Now when we add and subtract polynomials, this type of problem here, we're just going to combine like terms. Okay. Some students that I've taught in the past like to identify like terms with underlining, so I'll go ahead and just do that. It's a nice way to kind of see them. So for instance, I see an x squared here, I see an x squared here. Okay. I see an x here, that would be the same as the x that I see here. And I see a real number without any x's, I see a real number, the same type of thing over here. There's also this x to the third powered term, but it doesn't have a like term anywhere else, so it's just kind of independent, it's just kind of on its own. It's not going to add or subtract from anything. So when I go ahead and do this, I like to do it in descending order, meaning I'm going to start with the highest powered term and then go to the next and the next and etc. on down. So my highest powered term is the x to the third, and I am subtracting this x to the third powered term from this, well, not from anything. So I have first term is negative 2x to the third. Now I'm going to go with x squareds. I have 4 over here. I have 1 over here, and I'm going to take away the 1 from the 4. That leaves me with 3x squared. Now I'm going to look at the x's. I've got 3x over here. I'm going to take away negative x. Taking away a negative, as we all know, is the same as adding. So 3x minus negative x turns into 4x. And then now the real numbers, I've got negative 4, take away 2 is negative 6. And that's it. Typically we can do these like term problems in one step. If we identify the like terms, then we just combine them, and it's that easy. Now when we do products of polynomials, it's typically a two-step problem. We're going to do the product first, and then we're going to do the like term sort of thing that we did here. And that'll give us our two steps to kind of get us to our answer. Now when we do our product, we do kind of a distributive property. I like to draw lines, and since I've got lots of different colors, I'll change colors as well. I'm going to begin with this 2x squared. It needs to multiply to the 3x and to the 5. 2x squared times 3x is 6x to the third. 2x squared times 5 is 10x squared. Okay. Now let's change. Let's move to the x. X needs to distribute to the 3x, and x needs to distribute to the 5. X times 3x is 3x squared. X times 5 is 5x. Finally, I need to do this negative 1. It needs to distribute to the 3x, and it needs to distribute to the 5. Negative 1 times 3x is negative 3x. Negative 1 times 5 is negative 5. Once that's done, now I'm going to identify all of my like terms. Some x squareds, here's some x's, and I'm going to combine those like terms. So I like highest power first, that's the 6x to the third. I add the x squareds, I have 10 and 3 of them, which makes 13 of them. And I add the x's, I have 5, take away 3, giving me 2 of them. And I have my minus 5. And there's your product example. The other thing that we're going to cover in this particular section is how do we factor polynomials. And you can think of factoring polynomials as like undoing products. Okay, so the last example we just did where we multiplied those together, if I started with the answer and wanted to go backwards to the product, the way I would do that is by factoring, or what I do when I do that is called factoring. So we'll look at a variety of different types of examples. I like to group these types of problems into number of terms that they have. Okay, so let's begin with how can we factor polynomials that are made up of 2 terms. So we have maybe 3 different formulas. The first one is called a difference of 2 squares, or a difference of squares. If I have an a squared minus a b squared, difference of course means subtraction. Factors this way: a plus b, a minus b. We've no doubt all seen that before, so that shouldn't be new to us. Let's go ahead and look at the example of that first, and then we'll come back to the other formulas. Okay, my difference of squares examples. I got 4x squared minus 25. 4 is a perfect square, 25 is a perfect square, of course x squared is a perfect square, there's the difference, subtraction, so all the components, everything I need is there. I'm going to set up my 2 binomials, and the way we do this is we just take the square roots of each term. Square root of 4x squared is 2x. Square root of 25 is 5. One gets a plus, one gets a minus, and that's finished. There's nothing more to it than that. Now the second example is slightly more complicated because you look at it and you say, well, certainly there's the minus, there's the difference. I see squares on the x and the y, but the 12 and the 3, those numbers are not perfect squares. Well, what we have to do first on this particular problem is check for a greatest common factor. These 2 terms each divide by 3. If we divide by that greatest common factor, if we divide by the 3, and then we just keep it, it just comes along through to the end of the problem. What's left behind here, these are perfect squares. This is a difference of perfect squares. 4x squared square roots to 2x. Y squared square roots to y. One gets plus, one gets minus. And we have successfully factored this problem. Next, let's stick with 2 terms, but let's look at how to do it if they're cubes. Okay? Difference of 2 cubes. A cubed minus b cubed. Okay. Factors this way. The first factor is a binomial. It's just simply a minus b. The second factor is a trinomial. 3 terms in the second one. It's going to be a squared plus ab plus b squared. If it's a sum of 2 cubes, a cubed plus b cubed, it's virtually identical. It's going to be a plus b. Notice the sign just changed, but the sign changed here, so not to be surprised. It's going to be a squared minus ab plus b squared. Notice that all the terms are exactly the same. What changed was just the signs, which shouldn't be surprising because all that changed here was the signs. The sign pattern is same, opposite, always plus. Okay, notice it is same sign first, same as in the problem. Opposite sign of the problem, always plus at the end. First example, x cubed plus 8. So I'm going to set up, well, first of all, recognize that they're cubes. 1, I set it here, but x cubed is obviously cubed. 8 is a perfect cube, so we're dealing with cubes. set up a binomial and a trinomial. And if you want, you could certainly go ahead and put the signs in there because the signs are completely independent of the terms. Signs depend on the sign between them. There's a plus between them, so the signs are going to be same, opposite, always plus. Piece of cake there. Now we're just going to fill in all the terms. The binomial just takes the respective cube roots of the terms. So the cube root of x to the third, cube root of 8. Okay. Now the trinomial works this way, and usually I just use these terms over here to get the trinomial. The first term of the trinomial is the first term here squared. The last term of the trinomial is the last term squared. The middle term of the trinomial is the product of these two terms, and that's it. Last example. Recognize that these are cubes, the variables are cubes, the numbers in front are perfect cubes. So I set up my binomial, trinomial. In the binomial, I want the cube root of each of these. 27's cube root is 3, x cubed is x. 8y cubed becomes 2y. Over in the trinomial, the ends of the trinomial I typically do first. The terms that go on the ends are the squares of these. So 3x squares to 9x squared, 2y squares to 4y squared. The term in the middle is the product of these two. If I multiply these together, we get 6xy. And then the signs, we could do it at the beginning or the end. It doesn't matter. It's a minus to start, so we go same, opposite, always plus. Once you get that pattern down, these two-term type factoring problems are typically one-step type problems. Sometimes there's common factors and that might make it two steps, but typically they can be one-step problems.